Hello everybody, welcome to the fourth and I promise this time the final video of the binary systems. We're not going to do any conversions here, we're not going to do any multiplication, addition, no math in short. In this video, we're simply going to learn why we're learning the binary systems in the first place. So the reason we're learning the binary systems is, I'll just give an example, the memory system of a computer. Most of you are familiar with this system, but don't even actually know how it works. So, as I can guess, most of you watching this, normally, if you're watching this using a computer, your RAM should be like 4 gigabytes of memory. Your hard drive, maybe 500 gigabytes. Some of you can have a 2 terabyte. If you work at Google, you can even have a 5 terabyte. I don't know. So these systems you're seeing here of memory units, what do these units actually mean? Terabyte, gigabyte, or even a classic one, 4 megabytes. If you played games like on a Sega or Nintendo, you're probably familiar with this unit. Megabytes, gigabytes, terabytes, what do they actually mean? Now let's go back to the binary system and you'll see what these actually mean. So the digits which you saw in the binary system, that is 1 and 0, these digits are actually called bits. They're called bits, but a 1 is called a bit on its own, a 0 is called a bit on its own. It's just a bit, nothing else. It's a bit. So the computer, as you can guess, doesn't have a way of storing these numbers. As it can just store, like if I will say, my computer, store a 19 for me in your memory, it won't store this 19. Actually, it will store this 19 in the binary system. So this 19 converted to binary, I don't know what that 19 will be. We can do a quick conversion, but I'm trying to avoid the conversion. Okay, let's just convert it for memory's sake. So we can do that. We say 1, 2, 4, 8, and 16, and 32. 32 is the biggest here. So we need a 1, 4, 16, second biggest. What's remaining? We just need a 3, which is just this and that, nothing else. So 0, 0, and 0. So the computer won't store the 19 as it is 19. It will convert it to the binary system, which is just 1, 0, 0, 1, 1. The computer will store this in memory, not the 19. So you give the computer to store the 19, it gives you, bam. Me, I don't know what 19 means. I only know what the binary system means, and that's what I'm storing. This is all interpreted by the operating system and the language which you're running in. The computer knows what to do with the number you're giving it to store. You'll see this when we start doing programming using Java. We actually even need to tell the computer what type of number we're storing, because 19 is just an integer. In Java, you need to tell the computer that I'm storing an integer. It actually needs to know that before you can even give it to store that. There are also other numbers, like, let me say 3.1. 3.1 is not an integer. 3.1 is a decimal. In Java, actually code floats. So when telling a computer to store 3.1 in Java, you even have to say that, hey, this is a float, so store it as a float, and the computer will know what to do with that. Because although it's a 0.1, the computer doesn't even know what this 0.1 means. So it has a system of trying to convert that 0.1 to the binary system. So you need to tell it. So that's the reason why I was trying to stress out that the binary system is like the main system used by all computers for storage and all operations actually. So let's go back to the gigabyte, terabyte, and megabyte. So a giga just means a billion, it means a billion. Mega means million. Terabyte means, I don't even know what terabyte means. So there's a popular system. If you say 2 kilobytes, a kilo is just 1000 bytes. That's what it means. The K just stands for kilo, which is just 1000 bytes. And for giga, which stands for 1 billion. So which is like 1,000,000,000 bytes. That's the giga. For megabytes, it stands for a million, which is just 1,000,000 bytes. That's all to it. So you have a giga, 1 billion bytes, megabytes. I should have written it in the other way, like the mega being here, then the giga being here, because from smallest to biggest. But you see that. So let me clear out the board and we get into the good stuff now, where the binary system is actually working. I was just trying to give a simple demonstration of what these numbers do. So the system works like this. When you have 4 bits, like 1, 0, 1, 1, or don't care what this number is in the denary system, this is a nibble. This is called a nibble. A nibble is simply 4 bits. Then when you have 8, 0, 1, let me say 1, 0, 0, 0, 1, so this is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. When you have 8 bits, you have a byte. And that is 8 bits. Nothing to it. 8 bits. So these 8 bits make up 1 byte. So now, if we go back to that system whereby we have 1 kilobyte, how many bits do you think there are in here? Well, if you try to like convert, you have like 1,000 bytes. So let's try to see it. So you have 1,000 bytes. That's what you have. This is what it says. You have 1,000 bytes. And by the way, bytes is just represented by a capital B. For nibble, I'm not even sure. Don't mind the nibble. It's not even actually used that much. So 1,000 bytes. So since we know that the byte is simply just 8 bits, you can just say 1,000 times 8. This is going to be 8,000 bits. So 1 KB, as it known, is just 8,000 bits. That's what it is. Nothing else. So in the computer memory, especially the RAM, actually, it's a long tape of just repeated columns, and it keeps on going until it makes up this number. And by the way, this is not actually the number. I'll show that later, of 0 and the 1. So if you wanted to store the 19 in the 119 which I showed, it will just turn on these switches. So it will be a 0, 1, 0, 0, 1. I don't know what that number was, but boom, and there you have it. The computer has stored it by just simply turning on the switches. So it's representing a 0, it's off. A 1, it's off. And when it comes to read, it just reads that, interprets it back into a number. So that's how the computer is storing your information, or your memory, or your passwords, or your names in the computer. It's just simply using the bit system. That's why in programming language you even have to specify that, is this going to be a letter, is this going to be an integer, is this going to be a float, is this going to be that and that. You have to specify all that when you're programming. That's why I wanted you to look at the binary system, so that you can have a clear picture on how the computer is actually using that system. So back to 1,000 bytes here. We have 1,000 bytes. In real sense, it's not really 1,000 bytes. It's not really 1,000 bytes because of the 2 system, the base 2 system. 1,000 bytes is actually 1,024 bytes. And 1,024 bytes is simply 2 power 10 bits. That's what it is, nothing else. It's 1,024. The reason to this 1,000 is simply because it's by conversion. Actually, mastering the 1,024 is not an easy thing. You can master it, yes, but if we go into bigger numbers like 1 megabyte, and I tell you, Okay, tell me approximately how many bits are in 1 megabyte. That would be 1048,576 bytes. Those are the bytes in 1 megabyte, which is astronomically big. You can't even master this number. Later on, when you start programming, you'll see why this system will be very important to us, especially using the Java programming language. So that wraps up the video. Thanks for watching. Subscribe, leave a like. I don't know. Have a nice day, night, wherever you're watching us from. Goodbye.